Hello everyone, and welcome to this talk on Apex, what's new and what's coming. We'll be going over the Apex roadmap today. I'm Daniel Bellinger, the product manager for Apex, and I'm joined here today by...
I'm Anand Subramanian, principal engineer on Apex team.
And I'm Chad Deanhart, also a principal developer on Apex.
Okay. So because of the nature of this talk, we'll be making forward-looking statements, so it's important that you make your purchasing decisions based on products and services that are currently available. And in terms of what we're going to be covering today, there's 5 key areas, plus we'll go over the roadmap as well, or 4 key areas plus the roadmap. We'll talk about what we're doing for asynchronous processing in Apex, new features we're giving you to expand capabilities there. What we're doing for your quality of life as a developer, which basically means things that you've asked for from the idea exchange that we've been able to deliver on. What we're doing to increase your data processing capabilities, ways to work with more data or more flexible ways. And then finally, an update on where we're at with generics and where we're going before going over the roadmap as a whole. So first, let's talk about the things that we're doing for async processing in Apex and what's new in that space. We've talked about this, and it's a new feature that we're looking at launching, which is a capability for how you work with larger result sets outside of batch processes. And it's a feature we're calling cursors in Apex. And it's probably easiest to work through what it actually looks like in practice. So say you have a SOQL query. In this case, we're going to run a query over a large number of contact records. It's a pretty standard dynamic looking SOQL query, except we're asking for a cursor back for that SOQL query instead. And that cursor can be stored in a fully serializable variable called a cursor, surprisingly. And with that, you can synchronize it through, because it's serializable, you can pass it through instances of a queuable method. But the real interesting part comes when it comes time to actually use that cursor that you've requested. So here, in the queuable example, we're looking at the execute method fetching a subset of records from that cursor. So while there may be thousands or tens of thousands or more of records that match that SOQL query, you can ask for a subset of records back. And you have control over 2 parts from that. You have control over which position you seek from. The cursor is stateless. And you have control over how many records you'd like back from the cursor. So in this case, we're asking for the first 200 records, but you could ask for fewer or more, depending on what you need. And this gives you great flexibility, because the other part of the cursor is you can ask for the total number of records that you had, the total result set. So between those things, you can decide, do I want just the first 10 records? I'll process them. Maybe it was quite fast. I could process them more and ask for more. Maybe there was an issue and I need to roll back. Because it's stateless, you can adjust the cursor position back and forward. And it also means it's something you could apply in different scenarios. Say you wanted to do pagination. If you've ever tried to write a large pagination control for the UI, you would have found issues with SOQL queries only being able to work with the first 2,000 records via an offset. With this, you can actually paginate through the entire result set. It also opens up a number of more complicated scenarios. Say you wanted to segregate or separate the data into different queuable jobs. You could define different queuable jobs to work through each chunk of records with different offsets. So there's a lot of flexibility there, and that's a feature that we're looking at launching as a beta in summer 24 for you to try out. But that brings us to the things that we've been doing and working on to help improve your quality of life from the idea exchange. We appreciate all the votes and the ideas people raise from there. It really helps us in helping prioritize and design those features. The first one that we've launched in spring 24 is the null coalescing operator. This, so at a base level, everything in Apex can be null. Your integers, your strings, your objects, sometimes confusingly your booleans. And so it's important to consider what actually happens when those values are null. And the null coalescing operator basically gives you a syntax to say, if the variable I'm looking at is null, substitute this other value. Now you may have noticed that's quite similar to our safe navigation operator. That's for how you chain together a series of method calls and handle null anywhere in the chain. The null coalescing operator will do the substitution at the end if there was a null. So they're actually quite a nice complement to each other. And something to bear in mind about this type of operation is when we look at all the exceptions in production that can actually cause your transaction to terminate due to like an unhandled exception, 13% of them are caused by null pointer exceptions. So it's definitely something you want to be considering in your code base. In terms of syntax, it's pretty simple. If the left operand or the left part of the statement is null, it's just going to substitute the right part. And it's just 2 question marks. So pretty simple to use. But let's look at an example. So, and this is an example in conjunction with the safe navigation operator. So here we're writing a SOQL query against an account to get the billing city. That account may or may not exist. It may or may not actually have a billing city defined. And we want to build up a JSON to say how many matches on San Francisco do we get in the city name? Is it in San Francisco or not? And we're going to output JSON. So if that account was null, we didn't find it, and we didn't do anything, when we put that output out in JSON, we're going to get null. We didn't check for null condition. Whereas the null coalescing operator gives us a nice succinct syntax where we can say, actually, if it is null for whatever reason in that chain of operations that got me to where I am, I'm just going to substitute 0 because nobody wants to actually see null in that scenario. That's available in Spring 24. Moving forward from that, another feature that we've heard people asking for through the idea exchange is a universally unique identifier. This is a scenario that you could previously solve to some degree yourself. This example code here is one such attempt at that. It's quite actually a difficult thing to do, to actually generate a properly random, secure, unique identifier. And so for the similar reason that you probably shouldn't be implementing your own encryption.
Don't do Caesar cipher.
Yeah.
Yeah.
For the same reason you shouldn't be doing that yourself, you probably shouldn't be trying to generate your own universally unique identifiers. So instead, we've given you a nice simple class to generate that for you with a random one. And the important part is that's a version 4 UUID that is cryptographically strong from a proper pseudo-random number generator. It really just makes it so much easier for you. And that representation you can use throughout your code if you ever need to send an external ID that you're going to generate yourself. It's quite a much better mechanism than, say, trying to generate your own Salesforce ID outside of us assigning one. It's purpose-built for that task. Right. Another area that we've looked at expanding the capability in Apex. Historically, if you had a save point, you created a save point, and like in this example, and then you do some DML, something goes wrong. Here we've deliberately thrown an exception. And then you do a rollback. And after that rollback, you realize I need to form an external system that there's something wrong. I need to get the state in a consistent manner through that call out. And so you make that call out because you've done the rollback. Well, what would actually happen is you'd get an exception. And that exception would say, you have uncommitted work pending, please commit or roll back before calling out. And then you scratch your head and said, I just rolled back. That's really, really inconvenient. So I wouldn't be telling you about this if I didn't have a solution. And the solution is we've added a new method. And it's called release save point. And you'll notice some subtle differences here. So you can release that save point and then you can successfully make the call out. But there's some important considerations to make. One, you need to make the rollback and then the release. Just because you rolled back a save point doesn't mean you can't make further use of it and roll it back again. That's why they're actually 2 separate operations. You can roll back and then release it. It's important also that you do the rollback before you do the release, because once you've released it, you've invalidated it. You can no longer roll it back. So you've got to do those 2 operations in correct order. And that releasing of save points, much like the rollback, will do any child save points as well. And I think we added some additional logging as well when we do that release to help in your debug logs to help you see what's going on there. It just expanded that feature out of it. Again, that's available in Spring 24. Now, this is quite an important subject, and it's kind of interesting from Apex, and it's something we're going to need people to consider when in a future release. So it's probably easiest to talk about how private methods work in Apex through an example. So say you had an abstract or a virtual base class. Here it has a method, a private method, nothing particularly interesting about it, and a global or public method that calls that private method. Pretty straightforward. Then to that, because it's virtual, we can create a subclass of the base class. Again, pretty straightforward. To make it more interesting, let's make an instance of that subclass and call the method on it. What do you think happens? Well, it's the pretty standard thing. the global method will get called. Fine, all pretty standard. And then next, the private method will get invoked, which will invoke the private method of the base class. Again, pretty straightforward, nobody's surprised. So let's add a new private method to the subclass that just so happens to have exactly the same name as the private method in the base class. Doesn't have an override keyword, that method's not virtual. What happens today is the private method in the subclass gets called, which could create some new and exciting or unintended side effects for you or your customers. So good news is we've fixed it, but fixing it, we had to be careful how we fixed it. And to do that, we did it as an API version change on the base class. So you as the provider of the virtual or abstract base class can update the API version to 61 or higher, which will be the one that comes out in summer 24. And when you do so, it will automatically call the private method of the base class, as you probably intended. But if you don't update it, it will continue to function the way it previously did and call the private method of the subclass. I would highly recommend when Summer 24 comes out that you look and see if you have any virtual or abstract classes with private methods, and you update the API version and test them to see if you had any unintended dependencies on that private method behavior. Right, another area that we're looking to give you in Summer 24 is expanded capabilities around scheduled jobs. This is something that affects both developers and admins who often have to administer how those jobs are running. And first thing we're going to do is give you an easy way to monitor what your scheduled job usage actually is. So at the top of the page, there'll be a nice clear message that says you're using this much of your current limit. That way, hopefully, you'll be aware that you're approaching the limit before you actually hit it. And then we're expanding out the capabilities through the Setup API to have a number of features such as pausing and resuming jobs. You'll be able to see the cron trigger ID that's associated with a scheduled job. And you'll be able to also alter the cron expression that was used in the Apex code when that scheduled job was created. This is really beneficial because, well, one, you can see what schedule it's running on. I can see it's an interesting schedule. Was this one of our engineers made this example?
Yep.
Apparently he goes to the gym for 44 seconds on Tuesday and Thursday. Anyway, that's like developer testing. Yeah, but it's a very powerful feature. So say you're doing, a large data migration and you need to pause all your scheduled jobs without having to delete and recreate them. You can stop them all, do your migration, and then start them all up again when you're ready without having to reschedule them, find the correct user. It should make that job a lot easier. And with that, let's have a look at what we're doing for data processing. So this is another common request we've had through the idea exchange, and it's zip support in Apex. So this is like a fairly common scenario. We've had it from users like, I'm going to call out to some service, I'm going to bring some data in from somewhere. In this case, we're making a translation call out. We're saying, here's some text, translate this. And the service does that, and then when it comes back, it says, here, I have conveniently zipped this up for you so that the JSON isn't huge. And then you have to scratch your head and say, well, how am I going to get the data out of that? Now, there is a public library called ZipX, which is very clever. It does a lot of byte manipulation and will actually decompress that file for you. But in its cleverness, it is actually not ideal in performance. So what we've done, or what we have provided as a developer preview in Spring 24, is a dedicated zip reader and zip writer class that you can point at a blob or create your own zip and do so in a more efficient manner. Now, I should point out this is still happening within the Apex transaction, so you still need to consider what you're using in terms of heap and CPU for that operation. So it's not for working with absolutely massive files, it's more for working with succinct known files. With that, I would like to pass it over to Chad to talk to us about formulas.
All right, thanks,
Chad.
Yeah, I'm here to talk about formula evaluation in Apex. So formulas have been around for a long time in Salesforce, and admins are familiar with their syntax and functionality. To date, a package provider would have to work around some of this to get this sort of functionality into the Apex. And they would do that either by building their own rules engines to parse a string, and it may possibly have different syntax than what we use in our formulas natively in Salesforce. Another more common way to work around this is you would just add a formula field to an object and then query that object to get the value back from the object. So those workarounds suffer from a couple of downsides. One is that you're using up formulas, custom objects on the object, so those are limited. And also every time you have to go query it, you use a DML operation, which are also limited. So with formula evaluation Apex, you no longer have those two restrictions. And it also allows you to run in memory against multiple objects. So it also runs faster than the formula evaluation that we have today. We have a couple use cases that we see this being used for. You may have your own. There's conditional execution of triggers, per product pricing validation rules, and dynamic UI generation. With that, I'd like to kind of walk through a little bit how this would look or work for both a dev and an admin in the product. Again, this is in dev preview in spring 24, and we'll be going to beta in summer of 24. So you have your ISV who's distributed a package, and they provided a custom type for a formula, and as an admin, I need to enter a formula. So since I'm not good at writing formulas, I would probably go to the standard setup UI on an account like this, and I would use the formula builder to build my formula and also verify the syntax. I would then simply copy the formula from here and not actually save the custom field onto the object. So by copying it, then I can come over to my custom metadata type and create a record where I am then going to paste in that formula field that I just verified in the setup UI. So this is how it will look in the summer version of 24. This is the beta. This is how it currently works in the dev preview in spring 24. We currently don't have direct access to S objects in the formula evaluation, so we have to wrap them. And our wrapper class here is just simply an account wrapper which exposes account as a property of ACC. It's a global property. So with that, we can jump into, so at that point, the admin is done with his side of the work. Now the developer gets to use the formula by querying it back from the metadata record, which is the first bit here. After that, we just have a simple test account that we're creating. And again, we're in the dev preview mode at this point, so we're going to have to wrap that in the wrapper. The interesting part comes, we use the formula eval to create our formula instance, and we're going to pass some of these things into the builder. First, we have to define what our return type is. We're generating a custom text string here with our formula, so we're going to return a string. We pass in the wrapper class and the string formula we have. When we call build, it's going to go ahead and verify that our formula has been input correctly, and if there were any problems with any of this input, you'll get some kind of exception which you can handle and give feedback to the user. Since in this case, we verified in the setup UI before that it's going to work, we can go ahead and evaluate, and we see that we get our test account New York. I'd like to jump ahead to summer of 24, and I have another example here, very trivialized. This is not how you would actually write a trigger, but to get it to fit on a slide, we had to cut out a lot of the important stuff and leave you with just the formula evaluation. So here we're just hard coding our formula expression. You certainly can do that as well, but you would probably get it somewhere else more dynamically. We're going to go ahead, in this case, we're just going to return a Boolean. And now you can see that a few things have changed in our formula instance creation. Now the formula eval.formulabuilder.builder has been changed to just formula.builder because the other string is kind of a mouthful just to say, much less type. And we also have direct access to the account class here. We're going to then go ahead and initialize a list for our hot accounts that and then we're going to be able to iterate using our gifting formula and just evaluate all the accounts, and we generate our list. And now that we've sent gift baskets to all our hot new accounts, I'm ready to hand it back to Daniel.
Great, thank you.
Yeah.
So let's go over where we're at with generics. So some of you who were here last year may have seen this slide, but I think it's important that we go over why would we want generics in Apex and what would it actually give us. So I'll start with this code example here, which is a fairly common scenario. I'll walk you through it that most developers have probably come across. So you wanted to write a SOQL query. I'm going to get all my accounts back. And then later on, I'm going to do some processing on those accounts based on their billing country. Well, I as a developer know it's very expensive if I'm going to have to loop through that list of accounts every time I want to find the ones with a particular country. So I'm going to do the right thing. I'm going to bulkify my code. I'm going to spin through all those accounts up front, and I'm going to build a map. And the map's going to be keyed by the billing country, and it's going to point to a list of accounts with that billing country. Very common pattern. You probably find yourself writing it all the time. The problem is, as a developer, when you see yourself writing something all the time, you want to abstract it. You want to put a method, some sort of library, something to do that for you. But there's a challenge here. And the challenge is twofold. One, the type of the field that you're trying to map through could change. So in this case, it's a string, but you might be looking at an integer field. You might be looking at all sorts of types of fields. And the second part is the S object itself. Obviously, that's going to change. Here it's an account. I might want to be pointing it at different S objects. So to actually extract that away and to create a method that could be used all over the place is quite difficult. You might have to create versions for all the key types, and then you might have to resort to a lot of casting or dropping back down to object and then doing additional casting if you want to do so in a type-safe way. And that's where generics can actually help us out. A generic solution would allow us to abstract that away in a way that was both type-safe and reusable. And when I say type-safe, that means the compiler would actually be doing the enforcement for you. At compile time, you would realize if there was a problem with the types you were trying to push through that structure. Now, that's where we were a year ago. And to explain where we're at now and why this is a challenging problem, I'm going to give it to engineering.
Okay, folks, please don't copy the code that I'm about to show you. And do not pass code like this in a code review. So I'm going to explain a couple of problems with legacy generics in Apex using an example. Apex already supports generics. It's incorrect to say Apex doesn't support generics. It supports generics in the form of our collection types, that's list, set, and map, and all our built-in interfaces like iterator and comparator and all of the others. The problem, though, is that some of these types don't quite work just right. And I'm going to explain with an example here. Here, I have a requirement. I want to choose a furry animal as the mascot for Trailblazer DX. Right? And so I take my requirement, I have a developer write code like this that takes a list of animals and makes Cody the mascot by adding it to the list of animals. Sometime later, another developer comes around. They didn't quite understand what they were doing, so they created a list of mules, and then they passed the list of mules to my method that sets Cody as the mascot. Much to our disappointment, this code compiles. Not only does it compile, when you run it, it throws a runtime error. This is super bad. The runtime error here says you can't store a bear in a list of mule. And that's kind of bad because it did not prevent the second developer from making a mistake. The Apex compiler ideally should have been able to stop you there and say, you can't do this. You can't call a method with the wrong type. There's no such method. The other problem here is when you're defining your method, you're not able to specify a constraint. If you want to add a bear, you want to say, my method only take things that are bear or subclasses of bear, like polar bear or grizzly bear or, I don't know, any bear you like. So we don't have that ability in Apex today. So that's problem number one. Then we go on to another example. This example is more recent. We recently shipped the comparator interface that allows you to sort a list based on certain attributes. There's a developer who wants to try out the comparator. He wrote a sample comparator here called integer comparator. It compares two integers, doesn't do anything. Then another developer says, hey, let me try using your comparator. And they write a class called apply comparator. And the apply comparator class takes the integer comparator and compares things. Sometime later, for some strange reason, the developer felt, let me try this with strings. And so he decided to create a method called compare strings that takes a comparator of string and then passed it the integer comparator. Again, much to our great disappointment, this code compiles. And this code not only compiles, it fails when you call the apply comparator apply method, it fails with a runtime error that says, oh, you can't convert an integer to string. This is again a problem because we didn't prevent this developer from making the mistake. In today's age, the code you write may be a result of your understanding of the requirement or what the large language model you're using understood from your prompt. So it's kind of important that the compiler tells you when you make a mistake like this. So we at Apex team, we kind of felt, oh man, I wish it was a compiler error that says you can't do this. You can't invoke this method with an integer comparator. It only takes a comparator of string. So this is where we've hit an important roadblock. But this is where we are going to show you something new. And there's both some good news and some bad news. The good news is we have a solution. The bad news is the scope of the solution has increased. And I'm going to explain that with a code sample. This code sample has never been shown to anybody else before. So you folks are the first people to see it. Introducing parametric types in Apex. So this is a way by which you can tell the compiler, I want type-safe type arguments. Basically, at compile time, enforce the type safety of this, of the type parameters of my generic arguments. So what does that actually mean? There's a lot of things here, but I'm going to go explain one by one. This class that we have up here is a solution to the problem that Daniel brought up earlier, where we want to take a field type and a list of objects and basically be able to create a map keyed by that S-object field. And so to do this, I've created a map aggregator class that takes 2 arguments. Notice the colon. The colon is how you signal to the compiler, hey, I want you to enforce, I'm defining a type here. I want you to enforce at compile time the safety of this type. Notice also that the colon also extends to the collections that we are building inside this type. So the map and the list that we will be building inside this type also have to enforce this type safety. The second thing you want to notice is the second type argument here is v. V extends S-object. So v cannot be an integer or character or bear or whatever. It can only be an S-object. And when you use it in this example, we'll go look at how this map aggregator will actually be consumed by someone using your API. If you look at the black box to the right, you'll notice that there is an instance of the map aggregator. Map aggregator type arguments are string and account. So now you can't use a list of contact in there. We query a list of account, and we supply that to our map aggregator. Notice here, the SOCL query returns the old legacy generic list, and the map aggregator accepts the legacy generator list. So as part of building this project, we'll be providing a way to map or automatically convert legacy generic collections or types into new generic collections or types, as long as the type arguments are satisfied. If they're not satisfied, that'll be a compiler error. But as you can imagine, this has fundamentally changed the language. Our goal on the Apex team is to not end up on lists on the internet about funny things about the language. So that means, unfortunately, we do not have a concrete timeline for this project. All we have, though, is incremental progress that we've identified a bunch of problems, and we've found a solution, and we're working on it. For other things that are coming soon, I'm going to hand it back to Daniel to talk about the rest of the roadmap.
Wow.
Thank you, Anand, for all the hard work engineering put in on that challenge. Right. So that brings us to the roadmap. So there's the features that you have today to try in Spring 24. We would love you to go out and try the dev previews we have for Zip. We've had some great feedback already that we've been using to help structure how that feature looks going forward. And same with formulas. Go out there, try it in a scratch, or give us feedback about what works, what doesn't work, and the scenarios you'd like to solve with that. That will help shape the feature before we take it to GA. And then there's also the null coalescing operator, great tool to add to your tool belt for dealing with nulls, the universally unique identifier, and the callouts if you need to make them after save points through releasing them. So things you'll see coming up in the next releases, probably sort of summer 24 timeframe, forward-looking statements, an expanded beta of formula support in Apex, You'll be able to use that in more orgs outside of Scratch orgs. And as Chad mentioned, you'll have the extended support for working against S objects and the new the new builder syntax for making those. We've also talked about the capabilities you'll have for working with cursors. That's going straight to beta, because to work with a feature like that, you really need a larger amount of data than you'd have easy access to in a Scratch org. But that's another very powerful feature for working with large amounts of data. Beyond that, there's the scheduled job changes for the UI enhancements to allow you to pause and resume your jobs, to see the cron expressions that they're using, and to see what your current limit usage is tracking at. We're also working on a number of features around that integrate with the Apex language, so we're increasing your data cloud language support in Apex. One of the features that we're quite keen on people adopting is the ability to mock SOCL responses for working with data cloud entities. So previously, if you tried to make a SOCL query in your test context to get it to a data cloud entity, that wouldn't work. So we're going to add new methods that will allow you to provide a mock response just for data cloud entities in an Apex test context. So you don't have to modify your production code to handle testing scenarios. You'll be able to handle that straight from the testing context itself. And then longer term, obviously we're working towards taking the features that we've been working on in dev preview and beta towards GA. So we'll look at getting formula evaluation Apex to general availability, everyone. Same with zip support. There's other features that we've been working on around better testing support for post-install scripts from Apex to be able to run those directly in your test contexts. And then as we've gone through where we're going with generics, or I should say parametric types going forward. So with that, we would love your feedback on these features that we have in developer preview. That QR code will take you to a forum where you can provide such feedback. I'll also post the slides there if you'd like to see any of this content. And so I'd like to say thank you all for coming.